It's actually like this for a long time. This technology wasn't investigated in the 60s, 70s, 70s. People couldn't make it work. And why was that? Well, they have a lack of insight. The drops is invisible, charges invisible, electric fields invisible, wind invisible. Imagine debugging an IC engine in the late 19th century. If everything was clear, it a lot harder, right? So get that insight went to big models, so we have better testing. And those big models are computer generated models. Their computer back then, your iPhone has way more power in the room size computer had back then, right? And they had no visualization, whereas for us, one droplets to get pushed away from our source, which you're looking at here, the cross section of the car system. That turbulence you're seeing there is actually what the air looks like when it comes out of our panel. That's not what we want to look like, right? But now we know it, and so we can fix it, and we did. So we got rid of this turbulence. We can also fix our electric fields by looking at them, and there's powerful tool for us in moving forward. And move forward we did. It would be able to test outdoors, and we went from making no powers or less than no power, which is where people were 40 years ago, to gradually seeing our new experiments that will conform the models, create more power and more power until we finally hit 50, 60, 70, 100 watts per square meter, and then it's economically viable and really attractive as a real commercial power full source. And this is we actually did when we finally realized that we had made it to a point where we had a viable opportunity. And as a result of all that hard work and those insights, we were able to apply for and receive a very competitive grant from the Department of Energy Advanced Research Project Agency Energy, to a $5 million over the 2 years period. That lets us go from making lab-sized powers to the things we have in testing in very large multi-scale wind tunnel, and then next year to take it offshore, working with University in Maine on their offshore wind energy test bed out of the real live ocean, and test it for the very first time. So once you get that done successfully, which we got here, we'll get there. We're gonna go with the people in the water. This map shows you most of the world's populations lives right close to the shoreline, and it's crowded there. You don't want to have wind turbines there. But they're very expensive, far more expensive than offshore wind farms. So our system can make them cost comfortable to onshore wind farms, and change all that. And at the same time, remember that automotive heritage manufacturing technology this is a plant of GM's not too far outside of Detroit, big one. A plant the size though could, because of our high volume identical manufacturing technology and logistics that go with it, that plant could potentially supply half or more of the world's entire capacity from wind energy every single year, and be a great opportunity to do what? Create a panel at a time, but do millions of times, could unpause, and every time we do that, we create great jobs for people right here, our friends, our neighbors, the people we know. And at the same time, we know that we're not only doing all of that, but we're also creating an opportunity to change the world with wind energy, address climate change problems, and protect the planet that we all love, live on, and share. Thank you very much for listening.